Hi everyone. Okay, so this is question 17 of the revision questions, that document with 20 questions in total. And this question, what is it about? Let's read together. Two unbiased standard sided dice are thrown and the scores are recorded. So we are talking about two standard die. So we've got 1, 2, 3, normal die with 6 sides. And we've got 2 of those. Let's draw this to get a better idea what we're talking about. Okay, and then the scores are recorded. Let the random variable x be the sum of the two scores. So x is sum of scores. Okay, so we basically have the first die and the second die, so die 1 and die 2. And then we have, for example, if we throw 1 with die 1 and 6 with die 2, we will have score 7. If we have 2 and 3, we will have 5. It works like that, Okay, the probability distribution of x is given in the following table. Okay, so what are we looking at here? We have the probability distribution of x. So basically, we're going to have a look at all the possible values of x and the probability according to the corresponding probability. So does this make sense, guys? Why do we start with x is 2? So this is the sum. The sum is x, right? Does it make sense? Could we have x is 1? No, we can't, because we're going to throw 2 die and they are both unbiased. So we start with, if we have the minimal value, we will have 1 plus 1, which is 2. We cannot get 1 plus 0. That doesn't exist, right? A die starts with 1. So we have to start with x is 2. That makes sense. And then we have, for example, 2 plus 1 or 1 plus 2. So indeed, we start having 3, 4, 5, and we go all the way to 12, which would be 6 plus 6, right? Okay, so then all those probabilities, does this make sense? Why do we have 1 over 36? Well, why do we have 36 possibilities? We have die 1 and die 2. Oh, like this. And we have 6 options, 1, 2, 3, 4, 5, 6, and the other one 1, 2, 3, 4, 5, 6. So, right, this would be throwing 1 with die 1 and 1 with die 2, so we would have sum 2. This is throwing 2 with die 1 and 1 with die 2, so we would get 3. Blah, 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 blah. So we can fill in all these values, and this last one would be 6 plus 6, so that's 12. So how many possible outcomes do we have for the sum? That will be 6 times 6. Do we agree? So that's 36. So that's why we have 36 possible outcomes of this sum, right? And to get 2, guys, to get 2, the only option is to get 1 and 1. So this is just one possibility out of 36. We've got 36 up here. You see? So that's why it's 1 over 36. 3, however, that's interesting. We can get 2 with die 1 and 1 with die 2. So we get 3. Let me just put another color. That is 1. But we can also do 1 with die 1 and 2 with die 2. So in this case, we also get 3. So that are 2 options to get 3, and therefore the probability is not 1 over 36, but 2 over 36. You see? And 4 is also interesting. 4, you can get 4 by doing 1 with die 1 plus 3 with die 2, or you do 2 plus 2, or you do 3 with die 1 plus 1 with die 2. You see? So these two things are distinct different possibilities, because this one would mean throwing 1 with die 1 and 3 with die 2. That is a different outcome than having 3 with die 1 and 1 with die 2. So because it's different, we've got 3 possibilities to get 4, and therefore we get 3 out of 36. So this is how it works, guys. So this is our probability distribution of x. And now we are asked, first one, find the value of p and the value of q. Okay, so let's have a look at p. So p, A is the probability of throwing x is 5, isn't it? So we want the sum of our 2 dice to be 5. So what are the possible options to get 5? Well, we have 1 plus 4. This is die 1. This is die 2. So we've got 1 and 4. We can also do 2 plus 3. Or we do 3 plus 2. Or we do 4 plus 1. You see, guys? So we have 4 options to throw the sum 5. So we have die 1 having 1 and die 2 having 4. Die 1 having 2 and die 2 having 3. And this looks similar, but it's 2 distinct situations. This is die 1 having 3 and die 2 having 2. And this is die 1 having 4 and die 2 having 1. So that is different from this, you see? So basically we've got 4 options. So we've got 4 entries, 4 values in this whole big matrix of 36. And therefore, the probability will simply be 4 options out of 36. So the chance will be this, 4 out of 36. This is the probability of throwing a sum of 5. Then, how do we get Q? Well, now we have to be smart because now we have P is let's see. P is 4 out of 36. Yeah. And how do we get Q? Well, there are 2 options. Q. This is the probability of throwing x is 8. Well, there are 2 options, guys, because we know that with a probability distribution table, we know that the sum of all the probabilities will be 1. There's always something, guys. You always know that the sum of all the things must be 1, okay? Because one of these options must hold, and therefore the probabilities must add up to 1. So we could find Q by subtracting from 1 the sum of all these elements, and we know all of them as we know P as well. So you could do that to find Q, or you have a look again at the possible outcomes of x is 8. So how do we get x is 8? Well, let's have a look again. We have die 1 and die 2. Can we do 1 and 7? No, we cannot because the die starts from 1 to 6. So this is not an option, right? Can we do 2 and 6? Yes, we can. That is like a regular die. We can do 3 and 5. We can do 4 and 4. We can do 5 and 3. We can do 6 and 2. Can we do 7 and 1? No, we cannot, right? Because the die stops at 6. So this is not an option. So these are the possible options to find a sum of 8. So how many do we have? Let's have a look. We've got 1, 2, 3, 4, 5 outcomes. So 5 possibilities in our big table of possibilities that give a sum of 8. And therefore, this probability will be 5 out of 36. You see? So this is how we find this probability. So always make use of the possible outcomes, like what are the possibilities to get it, and you can just add them. So these are the possible outcomes, and this is the total number of possibilities. Okay, so that is Q. And then lastly, find the expected value of x. Okay, so expected value, I think you've seen this before. What is the expected value? Okay, so guys, if you have a table like this, the probability distribution of x, this table, you simply have all the possible values of x. So x is the sum, right? The sum of our two die. So the sum is either 2, 3, blah, 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 up to 12, and we have a corresponding probability of throwing 2 in total or 12 in total. So what we're going to do, the expected value of x, so the expected value of the sum is, so this is how it looks like. It looks a little bit scary, but this means simply, so if you see this in the answer sheet, don't freak out. This is sum. This means taking the sum. So this is basically, so suppose we call this possibility x1, this is x2, this is x3. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, x11. These are the possible values of the sum. So you see here that we have many doubles in this matrix, right? But yeah, so what you do, you take the possible value of the sum, the first one, x1, times the probability that the sum is equal to x1. That's what you do. Plus, again, you take x2 times the probability of the sum being equal to x2, and you do that until the last one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11, x11, right? x11 times the probability of x being equal to x11. So what it means, I'm just gonna put this away. So the expected value of the sum will be, let's have a look at our table, guys. So we have to multiply the first value of our sum times its probability, plus multiply the second possible sum value times its probability. What is the probability of throwing 3 in total? Plus, and we go all the way. So we do 2 times 1 over 36. That's the first thing. Plus 3 times 2 over 36. Plus, and we do all that stuff, guys. We have to put all that stuff in the calculator. So what will be our last value? It will be 12 times its probability. So we will have 12 times, and what's the probability of throwing 12? It's indeed 1 over 36. Why is it 1 over 36, as I explained before? Because throwing 12, the only possibility is to have a 6 on your die 1 and a 6 on your die 2. So this is one outcome. So this is only one entry in this matrix of 36 values. So that's why we have 1 over 36. Okay, so once you plug that all in, your calculator and you don't make mistakes, you will get, what is the value? 7. The value is 7. Okay, so what does this mean, people? This is the expected value. So this is the expected value of x. So, and what is x again? X is sum of die 1 and 2. You see? So x is that. So remember this formula? Expected value is taking the sum of all the possible values of x times its probability. So we simply take 2 times this, 3 times that, and we add all these elements up to 12 times 1 over 36. That is how you get the expected value of x. Okay? I think that's it. So this is really like a probability question. So important things to remember is that if we have this probability distribution table, the sum of all the probabilities must add up to 1. Then how to find a probability such as p. So you have to find a probability that we throw 5 in total. So again, you have to look at all the possibilities of finding 5. So you have either 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1. So these are four possible outcomes of 36. Why 36? Because we have 6 possible values of die 1 and 6 on die 2. So as you see, we have in total 6 by 6, like 36 options. And therefore, the probability here is 4 out of 36. So that is important to know, and this is indeed how you find the expected value. Okay, so this is good one to practice, guys, with simple probability questions. This is before doing binomial and normal and all that stuff. This is really the basics of probability. Okay, I hope this helps. See ya!